Hi, this is a video on vector components. Here's the idea. Let's say we have a vector, and I'm going to call this vector A, and we're going to say it is 20 meters per second. So it's a velocity vector at an angle of 30 degrees. Well, sometimes to work with vectors, it actually works best to break it into its component parts. So basically this is a way of deconstructing a vector into two different vectors, and those two different vectors act exactly in the x and y direction. So the reality is we could take any number of vectors and add them up to get this same vector. They could go in any directions, and as long as after you added all those arrows up, they ended up here, it would be equal to this vector here, 20 meters per second, 30 degrees. But what often works best is to pick components that are exactly in the x and y direction. So let's say this is our vector. We can have a component vector that we're going to call vector a sub x, and we're going to have a component vector that we call a sub y. And if you look at it, this is our starting point right there. A sub x plus a sub y equals vector A, right there, which is 20 meters per second at 30 degrees. So a sub x plus a sub y equal vector A. And we already know enough to figure out what a sub x and a sub y are. Because we know SOHCAHTOA, we know our trig identities. So a sub x is going to be opposite this angle 30 degrees, and we know the hypotenuse, so we can just say a sub x is vector A times the sine of the angle, which in this case is 20 meters per second times the sine of 30 degrees, which ends up being 10 meters per second. So a sub x is just 10 meters per second. Vector a sub y, we know that is just a cosine of that angle. Oops, made a mistake. Okay. Excuse me, ignore this. A sub y is opposite angle 30. So if we're doing the sine, it needs to be opposite. Sorry about that. So a sub y is a sine 30, so a sub y is 10 meters per second. A sub x is a cosine theta, and that means that is 20 times cosine of 30 degrees, meters per second. So that is going to be, let's see if I can remember my math, 8.66 times 2, so 17. 70.3 meters per second. Wow. Okay. If you picked up on this before I made the mistake, good job. I think it's important to leave mistakes in videos sometimes, which is why I'm going to do it. Keep you on your toes. Okay, a sub x and a sub y. So we know if something is moving at 20 meters per second in this direction, you can break it into components, and you can say, well, if you measure just its motion in the x direction, that x direction is 17.3 meters per second. So every second it's going 17.3 meters in the x direction, and every second it's going 10 meters per second in the y direction. And if you look at this, you say, well, the total speed is 20 meters per second. If the y speed is 10 meters per second and the x speed is 17.3 meters a second, you can't just add these together. You can't say 10 plus 17 is 27 because it doesn't equal 20. But remember, these are vectors. There's an angle which is why that this plus this, 17.3 plus 10, when you add them together, actually equal 20 because you're adding them as vectors. So we've broken this down to its two components. And if we want to add together two vectors, one of the easiest ways to do it is to add their components and then reconstruct it. So let's say that's vector A right there. We know vector A is 10 meters per second and 17.3 meters per second. Let's say that we have a vector B now. And I'm going to make vector B pretty easy. And I'm going to say vector B is equal to 20 meters per second directly north. So we can figure out B sub x and B sub y pretty easily. If it's directly north, look at this, and you can think about what component of this is going in the x direction. As time goes on, it doesn't move in the x direction at all, right? There's no x component. So in this case, x component is 0, and the y component is going to be the full 20 meters per second. You could recreate this using this angle of 90 degrees here if you want to, just like we did the last one, you'll get the same results. But I'm going to simplify it and say b sub x is 0, and b sub y is 0. So now let's add together vectors A plus B. Well, you could add these graphically, like we did in a previous video, where you say A plus B is that, and you get a resultant there, and you could measure the resultant. But now we have components, it's actually easier to add them mathematically. So we can say A plus B is equal to A sub x plus A sub y plus B sub x plus B sub y. But you can't add together the x and y components like just regular mathematical equations, as we've shown before. These are vectors. But the x's and y's you can add together. So the total x component is going to be 17.3 meters per second plus 0. So it's this plus this. So the total x component is 17.3 meters per second. And then the total y is going to be 10 meters per second, A sub y plus B sub y plus 20 meters per second. So the total y is 30 meters per second. So what does that give us? An x and a y. Still doesn't give us the length of the resultant, but we can find that pretty easily. So now we have a resultant that looks like this. It has an x component of 17.3 and a y component of 30 meters per second. .3 and 30 meters per second. If I'm going to draw this to scale, that needs to be a little short. So that's the starting point. Our resultant is going to look something like that. And this resultant here should be the exact same as this resultant here if you did it graphically. So now we're doing it mathematically. Now the resultant R should be really easy to find. You could use the Pythagorean theorem, for example, and you could say R squared equals 30
meters per second squared plus 17.3 meters per second, clear, squared. So you end up getting a resultant that is the square root. If the resultant squared is equal to I just need to look at this. I don't have a calculator with me. Oh, I do have a calculator with me. Here we go. So the resultant is going to be 30 squared plus 17.3 squared. So R is going to then be the square root of 1199 meters squared second squared. You can watch the units. So R is then equal to the square root of that. Or 34.6 meters per second. So you know this is 34.6 meters per second. And we could even find angle theta. And you can do this now that we have all three sides with the sine or the cosine or the tangent. But let's just say, for example, because this was a calculation, we're going to start with these two. We know that the tangent of theta is equal to opposite over adjacent. So 30 divided by 17.3 meters per second, The units end up canceling out. That's a good thing in this case. So the tangent of theta is 30 divided by 17.3. So we find that theta is equal to the inverse tangent of 30 divided by 17.3. And you can put that into your calculator, 30 divided by 17.3. And you do the inverse tangent of that. And you get theta is equal to 60 degrees. So this is how you can use that component method to add vectors together. You can also subtract vectors like this. You would just get negative signs in there. But you'll find oftentimes that adding vectors and breaking vectors down into components is really, really helpful for understanding problems. Because the last thing that I want to see is a problem where I give you vector A has got 20 degrees, or 20 meters per second. Vector B is also 20 meters per second. And I ask you to find the value of the resultant, for example, and you tell me it's 40. 20 plus 20 is 40. In this case, 20 plus 20 is not 40. 20 plus 20 is actually 34.6 at an angle. So that gives you theta is equal to an angle of 60 degrees. That is the end of the vector component video.